All right, friends, so today we are going to look at SAT practice test number 11, module 2. So I'll be posting module 1 and module 2 together. So let's get into it. Pretty good test. There's some really interesting stuff on here. There's one that I don't love, but overall, let's talk about it, right? So the first one, right, we're going to combine some like terms here, right? We get 11x plus 4y. Not much to say, right? Like always, guys, the first half or so I'm going to go through pretty quick. If there's something where you need more of an explanation, you can slow it down, or you can always post a comment. For the next one, right, how many had a diameter of 16? So we can count up those dots. It looks like there's 6 of those dots, right? It's a dot plot. Here it says, what's the area of the rectangle? So I'm just going to use the scale here to tell me that it's got to be D, right? It's the only one that's large enough. For number 4, I divide both sides by 10. I get x equals 11. So 6x is 6 times 11 minus 63, right, equals y. Right, so we get y is equal to 3. The question is asking us the value of y, so we'll take 3. Number 4, so this is one, if you remember from module, if you watched the module 1 video, they were asking us for f of whatever it was, your g of 7 or something, g of 81, I think, because it was square root of 81. Anyway, so, and I said in that video, I said, sometimes they don't give you g of something or f of something. They want to know what x is given that thing, right? So if f of x is 63, I'm not substituting 63 for x, which isn't going to give us one of the choices anyway, so they didn't do a great job with this question. We're going to substitute for f of x, right? So if 63 is equal to 9 groups of 2x plus 3, I would hope we know not to distribute here, right? To divide both, no, if you distribute, it's fine. 7 equals 2x plus 3, so we get 2x equals 4, so you get x is 2. Now, alternatively, you could have used some trial and error and plugged in your choices until you got 63, which would happen pretty quickly because it's choice A. But really, that's what they want you to do, right? It's not substituting for x, right? We're substituting for f of x, and we're solving the equation for x. Here, we get 8 and 6 cents. So one of the things we see on this test, not especially here, this doesn't matter. There's a lot of questions here that are good questions, but kind of like not satisfying. You get kind of crazy fractions or decimals. Some of them I had to check the answers. I'm like, really? That's what they wanted? Anyway, so that's kind of a little preview of that, I guess, even though that one's easy. All right, so we don't really have any numbers here, right? So when we have, and the one thing they do here is they mess with the variables, right? Typically, not that the a and the b could really be anything, but typically when we see an equation for exponential growth or decay, we have our initial value, right? And then we have our either growth or decay factor, right? That's going to be our b, and the x is going to be the number of periods, right? That's our model for exponential growth or decay. So if they ask you for the initial value, well, the initial value is going to be 3,600, right? A would be the growth or decay factor, and x would be the number of periods, but again, right, it's pretty straightforward here. This one, very typical. We saw one like this last time. Match up the coefficients, right? So it says each container is $1.87, and that's C. So we'd expect $1.87 C. A and B then become the same. Now, if we have a budget, right, let's think about it. The amount I spend can be less than or equal to 15. It can't be greater than 15. That wouldn't make sense, because then C and T would be infinite, right? So the cost is going to be less than or equal to $15. We match up our coefficients. Number 9 should be pretty obvious, right? We know what a linear equation looks like, even though that's not especially straight. So this is clearly exponential. It's going up, so it's increasing, so increasing exponential. So far, so good. This one, we need to remember that we have horizontal lines, right? X equals 3, right? That's going to be a horizontal line, right? That goes through 3 on the y-axis. And then, of course, right, we've got our vertical lines, right? So if I wanted x equals 3, that would be a vertical line that goes through 3 on the x-axis, right? So I've got a horizontal line here, so it's going to be y equals, and since it's an inequality, we want the values that are above, so we want the y values that are clearly greater than whatever that number is, 36, right? If there was an issue with the solid or broken, we would realize that since there is, you can't really see it because I wrote over it there. Let's go back. Yeah, we have a solid line here, right? So a solid line means you have the or equal sign underneath there versus a broken line, which wouldn't. That's not the issue here, but just something to think about. All right, there's 240 people, and it's single elimination. So with single elimination, every round, half the people are going to lose. So our decay factor should be half. And there's 240 people to start, so just like we saw before, right, that's my initial value. So there's 240 people. Every round, we lose half of those people, so it should be 240 times half to the number of rounds power. Number 12, we know that parallel lines have the same slope. So that's really all we need, right? If I know the slope is 6, I don't need to go any further there, right? Yes, I see that the y-intercept is 5, sure, right? But all of them have a y-intercept of 5. That's kind of throwaway information. All right, so let's see what we have. We have a right triangle. We have 2 equal sides, which means the angles opposite must be equal, which means we clearly have an isosceles right triangle, which means both of those equal angles opposite the equal sides will be 45 degrees. Again, so far so good here. Radius, we talked about this in the video for Module 1. We know that 169 is equal to the radius squared. Very conveniently, it happens to be a perfect square, and if it was not, we would just simplify the radical. We get 13. All right, this one is just interpreting the problem, right? So we have blah, 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 all this weirdo stuff here, right? X grams per mole. So 149.02 is the number of grams per mole. And then it says that this is going to be the boiling point, right? So the boiling point should be 186.5. The molecular weight is going to be X. That looks to me like choice B, right? Molecular weight is X, and the boiling point is going to be the value of Y. All right, for the next one. So they're giving us the roots of a polynomial. Well, where did those roots come from? Well, we take the opposite of each X value. Right, so this is a way to write the equation. In other words, right, so if this is f of x or y equals whatever, right, could I have a coefficient here, 4 or 7? Who cares, right? There could be a number out there, but the point is, whatever coefficient is outside doesn't really matter. So when I solve this equation, I get x is -5, I get x is 1, I get x is 4. So it's kind of like the reverse of what's there. So let's see, do I have x plus 5 as an answer choice? No. Do I have x minus 4 as an answer choice? No. Do I have x minus 1 as an answer choice? Yeah. Right? So it's just like with the quadratic, right? We know that, you know, if I'm factoring something, right? Just as an aside here. Right? What happens when I solve this equation, right? X is 5 and x is -3. So sometimes they'll say, well, if I give you the roots, what are the factors? And what happens is we work our way backwards and we take the opposite of each of those signs. And this is kind of the same thing. If you're giving me -5, right, as one of the roots, then x plus 5 must be one of the factors. So the only one conveniently that matches up is choice C. 17. So we can do this in a few different ways, right? We want the equation of this line, but really we just want the y-intercept. So if we were doing this in school, I'd say, hey, let's choose 2 points, let's find the slope, right? And let's use that to find the y-intercept. But the other thing we can do, if we have a table like this, is I say, let's run it back to 0, right? Because the y-intercept is the y value when x is 0. So we realize that as x increases by 1, y decreases by 4. So what happens if x is going to decrease by 1, y is going to increase by 4? So what would complete this table? 36, right? Because the y-intercept is 36. Now as x increases by 1, y decreases by 4, increases by -4, and that should be choice D. All right, this one is a little, I guess it's a little bit unusual, right? So like, one thing we can do is we can think about what this graph is going to look like. It's not going to be super helpful, right? So like I'm going to have 24, -8, all right? Let's say that would be here. I'm going to have 30, -8. That's here. I'm going to have 32, +8, right? Which is going to be up here, right? So like something like that, right? So really we're interested in kind of finding the vertex, right? So it says which equation? So really what we want to do is we want to think about, like, how can I substitute these values, right? In other words, if I substitute 24, it's going to give me -8. And I'm going to say, well, I'm going to look at these two, and I'm going to say, well, with the first one, if I substitute 24, it's going to be 0, and then it doesn't matter what x minus 30 is, right? That's going to be 0, and it's going to be 4. So 24 would give me 4. Well, that's no good. So that's kind of a clue that that's really what we're looking for, right? Because what's going to happen with the second one? Well, if I substitute 24, it's going to give me 0 times who cares, minus 8 is negative 8, so that checks. And if I substitute 30, 30 minus 0 is 0, so 0 times who cares is going to be 0 times negative 8. And if we really want to do our due diligence, we can substitute 32 and make sure it gives us 8. So I'm going to get 8 times 2 minus 8. Not that we need to do this, but it works. So really we're looking for this here, and we're also looking for this here. So this one kind of checks all those boxes. All right, this one's pretty unusual. So it says we've got these two types of stars, and the estimated mass is whatever, quatergrams, whatever that is. This shows the possible combinations. So it says, based on the graph, which of the following is closest of each M-type cluster, M-type star in the cluster? So I'm going to use the intercept here. And I'm going to say, well, 160 times x would have to give me this number. So I'm going to divide this by 160. And it's going to give me closest to this, right? In other words, so this, just as a reference, right? So this point would say that 80 M-type stars plus, I don't know, whatever this is, let's say 60 K-type stars is equal to 127,882. So really what we want is, what if it's just M-type stars? Well, 160 M-type stars would be equal to 127,882. So that's why I'm dividing by 160, and I'm going to say, well, that's going to be closest to choice A. Really odd question. Okay, here's another one. Super unsatisfying, right? We do all this, well, we say, first of all, for a number 20 question, this is pretty hard. Okay, so a couple of things we want to remember here, right? If I have something like a fractional power, right, the numerator represents the power, and the denominator represents what we'll call the root, or sometimes mathematically we'll call it the index. So this is the example I generally use. So if I wanted 8 to the 2/3 power, I can do 8 to the 2nd power, right, because the order is not going to matter, and then take the cube root of that, right, which is 4, or alternatively, I can take the cube root first, raise that to the 2nd power, right? So that's how fractional powers work. So I'm going to say, well, this is the cube root of p squared. Okay, well, that would really be p to the 2/3, right? Because it's p to the 2nd power, but then the 3rd root. So p to the 2/3 power is equal to t to the 9/7 power. And it says what t is equal to. So I'm going to want to solve this thing in terms of t. So I'm going to raise both sides to the reciprocal of the exponent, right? Because when we raise a power to a power, we multiply the powers. And I know the product of anything and its reciprocal is 1. So on the right side, t to the 9/7 to the 7/9 is just going to be t to the 1st. Now on the left side, I'm going to get p to the 14/27. I say, whatever, not satisfying yet. So if t is equal to p to the 14/27, then p to the 14/27 is equal to p to the 3n minus 1. In order for these to be equal, the powers must be equal. So when I saw this equation, I said, well, maybe I'll get some sort of kind of logical type fraction. Not really, though, right? So I could do this in a lot of different ways. I'm probably going to add 1 on both sides, right? So if I know that 1 is 27/27, this is going to give me 41 out of 27 is equal to 3n. I'm going to divide by 3, which is the same as multiplying by 1/3. And that's going to give me 41 out of 81 is equal to n. So I had to do this a couple times because I said, why would anyone make a question so unsatisfying where you get such a kind of wacky fraction? You can't even simplify the fraction. Sure enough, I checked the answers, and that's what it was. So, again, kind of unsatisfying, but that's the procedure. So as far as question 20 go, I thought this was pretty hard, right? You had to know a lot about fractional powers, how we can use power of a power property. Solving the equation is not especially easy, but that's what it looks like. All right, so this one shouldn't be too bad, right? So B is 320% greater. So if it's 320% greater, that's like saying 420% of, right? Because if it's 320% greater, it's the entire thing itself, whatever itself is, plus 320% of itself. That's 420% of itself. So really what I'm doing is I'm taking 160 and I'm multiplying it by 4 2/10. Right? That's like the same thing as if I multiply by 3 2/10 and then added it to itself, because I'm taking 100% of it plus 320% of it. Now, number A is 55% less. Well, again, 55% less is 45% of, right? Because again, if I think about the entire thing, if I have 55% less than my 100%, I've got 45% of it. And this was another one, to me, not really satisfying. They could have given us one here where the solution was an integer, right? They decided to give us something where it wasn't, and this is another one I did it a few times just to make sure what they were looking for, and sure enough, we do get 302 and 4/10. Okay, now again, I know you have a calculator. I'm old school. I'm going back to the days where part of it we didn't have the calculator, and I would always think about, I did this mental math. I said, well, let me do 160 times 42/10 times 45 hundredths, or really times 9/20ths, right? So I worked this out, using fractions instead of decimals, but it was just kind of unsatisfying. Anyway, that's the procedure. So this is what we want to do. We don't want to be taking 55% of this thing and subtracting it from itself. We could, but we want to think about doing it in just one single step, and that's really what we should be doing. All right, so this is one, when I was talking about Module 1, I said, I don't understand these questions. Which displays a certain value as a constant or coefficient? I'm not really sure what they're trying to assess from us here. But anyway, what I'm going to do here is I'm going to try to put this thing in vertex form. Right? I can put this in my calculator if I want. Right? You don't need to see me put something in a calculator. I'm going to put this in vertex form. So I'm going to factor out -6. And it's not going to be the easiest thing to put in vertex form, I'll be very honest. So we need the trinomial here to be a perfect square. So if I have x squared minus 10x, and I want a perfect square trinomial, I want the constant to be -10 divided by 2, which is -5 squared. So I want it to be 25. So I want this to be -10x plus 25, but I don't have 25, I have 21. So that's how I'm going to call this like reconciling it. So as of right now, if I was to distribute what I have in red, I'm going to get the original equation. I haven't done anything strange. I haven't changed this. But now what I'm going to do is I need to get that -4 out of there so I can factor this as a perfect square trinomial. Now here's the problem, right? This is not -4. This is -6 groups of -4. So when I bring this outside of the parentheses, I need to multiply -6 by -4. Now if I was to redistribute, I'm going to get -6x squared. I'm going to get positive 60x. I'm going to get -150 plus 24 is -126. So I just do that as an example to show you that everything I did so far, mathematically. All right. So now I'm going to do what we do when we want vertex form, which is factor this as a perfect square. All right, so now we got to go back to our Algebra 1. What is vertex form? Well, vertex form means the vertex is going to be, and I have my answer, I realize that, but my vertex is going to be the opposite of this term as the x-coordinate, and this as my y-coordinate. Okay, now, if I look at my equations, I see my answer, right? Now, what's the maximum value? Well, think about the fact that this has a negative coefficient, so my parabola is going to look like this. So 524 is my maximum value. Now, when we talk about a maximum, we're really talking about the y value, right? How high up or down it is. So there it is, right? So it turned out that by using vertex form, I had the exact equation. But if you just used your calculator and you said, oh, I used my Desmos or whatever, my maximum is 524, there it is, right? So you can do it that way too. All right, so pretty interesting one here, right? So let's think about what we know, right? These two angles are equal, and of course my vertical angles are equal. Maybe I'll do it this way instead. Let's call them angles B and B, which is different color. And let's call this angle C and C, right? Because if angles B are vertical and A are equal, two angles in a triangle are equal, the third one also has to be equal. So I've got similar triangles. So let's label the information, right? YQ is equal to 21, and WQ is equal to 70. Let's do this. And WX is equal to 60. All right, so let's think about it. I've got similar triangles. So this side, 70, I'll call that the C side because it's opposite angle C, is to what I'll call the B side, which is opposite angle B. In is the same thing in my other triangle as the C side, right, which is 21, is to the B side, which is they're trying to find. Right, so there's my proportion. Right, so what would be an easy way to solve my proportion? I'm going to take that down. Obviously, again, we have a calculator. We can cross multiply. I'm going to multiply by 3. I'm going to multiply by 3. So we get x is 18. All right, so that one is just rooted in using some similar triangles. I didn't even notice, right? Could we use this? Let's see, xq is 120. All right, so it's 60, 70, 20. So my ratio here is going to be 6, 7 to 12. So it's basically multiplied by 3. So this would be 36 because 3 times, so it's a scale factor of 12. So 3 times 6 means this would be 18. 3 times 7 is 21. 3 times 12 is 30. So this was like extraneous information. I didn't even notice that we had it, to be honest. All right. So how many distinct solutions? So this is technically a 7th degree equation, right? Because if I multiply this together, which we're not going to do, I'm going to get x to the 7th. So on the surface, right, the degree tells us how many roots we could have. So up to 7 roots. And I can't remember ever solving a 7th degree equation, but it's possible. So here's what I'm going to do. I'm going to divide both sides by 52. Fantastic. The 0 is still going to be 0. So here's what we've got, right? X cubed plus 64 can be equal to 0. And x to the 4th minus 81 will be equal to 0. So we have 2 distinct equations. So I've got my cubic equation. Now remember, it's okay to have a cubic that's negative, right? So if I take the cube root of both sides, I only get one root though, right? Because obviously if x is 4, 4 cubed is 64 plus 64, that's not 0. But negative 4 absolutely works, right? Negative 4 cubed is negative 64 plus 64 is 0. That works. What am I going to do here? X to the 4th is equal to 81, right? Or probably shouldn't do that. I could. Let me factor this using difference of squares. Right, so I'll do x squared plus 9x squared minus 9. Right, I'm going to factor this completely. So we get x equals plus minus 3. Right, so that tells me I've got 3 roots. Right, negative 4. If I check, that will work. If I substitute 3 over here, that's going to give me 81 minus 81 is 0. That's going to work. If I substitute negative 3, it's going to give me negative 3 in parentheses to the 4th is 81 minus 81 is 0. Right? So we get 3 roots. So we do have to do some solving there, right? Yes and no, right? I guess the fact that this is a cubic here with a positive or negative means we're going to get 1 root there. The fact that this is going to be a positive power with a negative means there's going to be 2 roots there. I like to solve it just to make sure. And if they're radicals, that's fine. All right, so this is a pretty typical one. This shouldn't require really any math, right? The histogram shows 50 players. Someone else shows up that scores 18 points. Okay, so we got this one person that didn't do well relative to everyone else. So without looking at the choices, what's going to happen? It's going to make the mean lower because we got this person that did very little. It's going to bring our mean down. Now, what about our median? Well, it depends. I got a pretty large chunk up here. Right, so if my median is in that group, right, so there's 50 people. So the median is going to be between the 25th and the 26th person. So if there's, 4 people here, let's say there's 7 people here, that's 11 people. Median is going to be somewhere in the middle of this chunk. So adding 1 person or 2 people is not going to change my median. So one says the median is going to be less. No, the median's not going to change. Well, the mean is going to be less. That's absolutely true because that person's going to drag our mean down. All right, really typical question here on similar triangles, right? So it says we have a right angle. Now this one is a little bit tricky, right? So x is going to be 90 degrees. I don't really care so much where y and z are. And it says w is on yz. Okay, so I'm going to throw w on yz, and it's going to be perpendicular to... WX is going to be perpendicular to YZ. Okay, fine. So I'm going to put it here, right? So it's essentially an altitude. It is an altitude. Now, we know that before I do anything else, we know that when we have this sort of setup, we have similar triangles. Now, I teach this a little bit differently. I'm going to say if I call this angle A and angle B, right, that would make angle B, A and B complementary. Now, on the right, I've got this right angle here, which means that this would be angle A, and I've got a right angle here, so this is angle B. So I've got this triangle with angles AB and my right angle. I've got this triangle with AB and my right angle. And of course, I have my big right triangle, right? So if you've studied some geometry and you've worked with altitudes, you know we have this kind of cool relationship here. Okay, so so what's the value of tan Z? So I'm going to do this before I do anything else. So tan Z, right, so this is going to be my theta, is going to be the opposite of that, right? So it's what I'm going to, well, I guess it depends. So let me go ahead and fill this in there because it's going to depend where it is. So WY is 572 and WX is 429. Okay. So here's where I kind of got a little bit ahead of myself, right? So the tangent of Z, right? The tangent of Z is going to be the A side, right? So tangent of Z is the opposite of angle Z over the adjacent. So it's going to be the A side, what I'll call quote unquote my A side, right? That's the opposite over the adjacent, right? That's going to be this. That's going to be what I call my B side. And my A and my B sides are just the sides opposite what I'm labeling those angles as. Now, since these are all similar triangles, I can use any one of the triangles. So I'm really going to focus on this triangle because that's the one I have to measure up. So the A side is 572, and the B side is 429, and simplifying this gives me 4/3. So again, there was a lot kind of wrapped up in that question, right? It's a matter of, can you take angle Z, which in that triangle, you only have one side, so not enough to use a ratio, but realizing that because they specifically started off by giving us an altitude, that the triangles would be similar, and then using, instead of XWZ, using XYW, and realizing that since it's similar, we can use the same ratio of the same sides in that one. So that was a tricky one. All right, so something that we want to understand here, right, is the way that we do unit conversions when we're talking about square and cubic units. So I'm going to start with a simple one, right? I'm going to say that 3 feet, 1 yard is equal to 3 feet. Now, if somebody wanted to know about a square yard, right, a square yard is not 3 square feet, right? A square yard is 1 yard squared. Well, 1 yard squared is 3 feet squared, which is 9 square feet. And if we wanted to know about a cubic yard, 1 cubic yard would be 3 feet cubed, which is 27 cubic feet, right? Because area is a square measurement, so we have to square our conversions. Volume is a cubic measurement, so we have to cube our conversions. And that's going to be important here. Again, kind of not satisfying because they gave us unnecessary decimals, in my opinion. So I'm going to say, okay, 1 nautical mile, I'm going to call that N, equals this. Is that really necessary? No, I don't think so. But so what's a square nautical mile? Well, 1 nautical mile squared is equal to this thing squared, right? Now, when I did that, I got it. Right? Checks notes, as they would say it would be 3.4299. So I'm going to say about 3.43, right? Technically, it's 3.4299. Again, unnecessary. So now it says, well, what if I had 46 of these things? Well, okay, I can multiply both sides by 46. Again, kind of unnecessary. So 46 nautical miles squared is equal to, in this case, 157.78. They wanted to round to the nearest tenth for whatever reason. So now they can't just have us round to the whole number. They're assessing whether we can do all this stuff and appropriately round. We get 157.8. So again, some of these questions that the numbers, whoever created them, not the most satisfying, but the mechanics of it were good. So I hope you guys got something out of this. As always, questions, concerns, anything else that you want to see in the future, just let me know in the comments. Thanks for watching.